Hi, my name is Edgar and I'm a student of mathematics at the University of Hamburg. And in this series I will walk you through the entire process of building and training a neural network inside of Python from scratch. And I mean entirely from scratch. So obviously we won't use any of those machine learning libraries like PyTorch or TensorFlow, but more importantly, we also won't copy and paste any of the formulas we will need from ChatGPT or anywhere else from the internet. Instead, we will derive all of the formulas we'll need by ourselves, by hand, only using pen and iPad in my case. Now, the goal of this series will be to build and train a model on the MNIST dataset, which is a huge collection of, I think, 60,000 handwritten digits along with their label. And in the end, our model will be able to achieve an accuracy of about 93%, depending on the model size, on the training set, which results in an accuracy of about 50% on the digits I draw with my mouse myself. Now, of course, these results are worse than if you had just taken any off-the-shelf convolutional neural network along with the Adam optimizer. But given the fact that we will only use basic college-level math, I think it's pretty amazing that this even works at all. But of course, as I just said, we will need college-level math. So let me tell you about the math we will be using so that you know whether you can follow the series or whether you need to revisit some of those topics. So first of all, we will need basic mathematical notation. We will need a lot of indexing because we have a lot of objects to keep track of. We will also use indices to write down sums or define sets and tuples, etc. So again, mathematical notation you learn in college. And second, we will need to take the matrix product of a lot of Jacobian matrices. So this means that we will need matrix multiplication and taking the Jacobian of a lot of multidimensional functions. So again, if you don't feel really comfortable with any of the things I just said, then you need to revisit that. Except if you really don't care about the math at all and just want to see the implementation into Python. In case that's you, then you can also just watch the second half of this series. Because so I've structured the series in a way where in the first half I will calculate and do all of the math by hand. And then in the second half implement all of the calculations. So there will be no more math in the second half. So before I end the introduction, I want to give you an overview about the videos of the first half that will be coming up. So the first video is going to be all about defining our objects. Specifically, we're going to define the forward pass on the loss function in a way that's mathematically tight, so that we can actually do calculations properly once we want to do the backpropagation algorithm. But before we actually calculate those gradients, there will be a second video in which I want to give an intuition about why the multidimensional chain rule is even true. So I won't prove anything, it's really just about the intuition. And also I will introduce a lot of compact notation in that video that will make our calculations much more readable and easier to work with, because the chains of the multidimensional chain rule can get really long. So if we don't have notation to keep it short and precise, then we will drown in a sea of indices. Okay, and so after that, in the third and fourth video, we can finally actually compute the gradients, first of the last layer and then generalize the calculation to all of the other layers. And then finally, in the fifth and last video of the first half, I will make the computation that makes the softmax activation function and the cross entropy loss harmonize so well together, which is the reason they are so popular in the machine learning community. And we will also use these both in our model, and since we can't look the results up, we make the calculation ourselves. So that's it for the introduction. That said, I just hope I see you in the next one. Bye!